Well, hello and welcome to today's lesson. We're going to be talking about direct variation. You might have had this before, but I do want to do just a quick review. So a direct variation is a specific relationship in which there is a constant we call a variation between two variables. This constant of variation, we use the letter K to represent it. And so our equation is y equals kx, okay? So one of the things about a direct variation, I'll put it over here to the side, how you're going to tell whether it is a direct variation, because if your x gets bigger, then your y has to also get bigger. They're going to do exactly the same thing. If your x gets smaller, then your y would also have to get smaller. Now, there are other types of direct variation other than just a linear. You could have it also y equals kx squared would also be, and then in which case it would say it varies directly as the square of. So there are, but for this lesson, we're going to focus on just the linear, which is what we've been doing. So in order to identify the constant of the ordered pairs, what it says, identify the constant of the ordered pair below, then write the direct variation equation. And so what we're looking for, basically, our K value is our slope, okay? And so when I come in here and I look at my values, if you'll notice that your X's go up by ones every time, and then your Y's go up by 4 every time. So in terms of my K, and the change in the Y is 4, and the change in X is 1. So K is actually just 4 if you want to write it that way, okay? So my equation would be Y equals 4X, okay? Next one. So the rest of those are going to work the same way. So now the thing is if there is not a constant, in other words, it's changing exactly the same, then you're not going to be able to write the equation, okay? Let's see, I'll go ahead and do another one here. So I'll do 3. So when I look at the change in my X here, you'll notice that this goes up by 6, up by 6. This one goes up by 3. Let's just see what happens here. So I'm going to do my Y's, and I see that this went up by 4, because I'm going from a smaller negative to a bigger negative. This one goes up by 4. This one goes up by 2. So when I look at this, it is still going to be direct, because if I take 6 over 4, I get the same thing as 3 over 2. So my K value, or not, the reverse of it, sorry, but either way, but since we're doing our K value like slope, it would be the Y's over the X's, so I would do 2 over 3. Okay, so my equation would be Y equals 2/3 X. Now you could definitely run your slope formula and do that also. So that's all you're going to do to those problems, okay? The next one, identify the equation below that represents a direct variation. So a couple of things about direct variations is, one, when you do a direct variation, it is in the form of y equals kx. There is no plus b like that is in your regular slope formula. So there is no b value. Okay, so when I come looking at this, again, here is your y equals kx. Okay, and so yes, that one is, and my K would equal 3. Okay, this would be a yes, because it is Y equals KX, and my K would be a negative 4/5. Okay, now this one does not have an X. Okay, so when I look at it, is it in the form of Y equals KX? The answer is no, there's no X. Okay, now some of these you will have to solve first. So an example, this one I would need to solve first. Y equals 5/2 X. Now it is in the form of Y equals KX, so K would be 5/2. But if you look at this one, again, it has that plus B on there. There's a plus or minus, so this is a no. Okay, So basically, it is a very simplistic linear equation going through the origin. There's not going to be a VB value. So some of those you can tell real quick by looking at them. Okay, in terms of a graph, again, since we are looking at the equation y equals kx, okay, again, there's like a plus 0, so it needs to go through the origin, okay? So when I look at it, yes, this one goes through the origin. No, yes, yes, okay? And then the rest is to find the constant of variation. So that is just like your slope. We just call it k. So I'm going to rise 2, run 3. Here, see, I wouldn't do number 15. On this one, I would down 1 and right 1, 2, 3, 4, right 4. Okay? So you would need to go back on in 17. Okay? So if the following order pair represents a direct variation, find the missing value. Okay? So what we're going to do is y equals kx. So step 1, we need to find k. Okay? So to do that, we substitute x and y, okay, in equation. Okay, so in this case, I'm going to put in so k equals a -2. So my equation here is y equals a -2x. So now I need to find y. So I just go to my other equation and substitute in my x, so y is 12. Okay, so my answer would be 12. Okay, so it's a two-step problem. First, you got to find k by substituting in your x and y into the equation and solve for k. Then we're going to write our variation equation with k. And then again, we're going to substitute either x or y and find the other. Okay? And those will be your steps that you'll do on those. Same step every time.